Okay, so we got this kid who has to pass. And by the way, this problem is definitely in the realm of unrealistic. When you run, can you accelerate like for a long period of time? No, dude. Like that means that as you're running, you're going faster, faster, faster. Maybe if you're like the bionic man or the bionic woman, you could do that. But typically, you have a very short period of acceleration, and then you move with constant velocity. But physics problems. I got this problem somewhere. I forget. It's not very realistic because you're not going to accelerate constantly as you're running. Okay, so this kid has to pass a physical ed class, and he's got to run a mile in 12 minutes. So after running for 10 minutes, he still has 500 yards to go. So look, is this 1 mile going to matter? Not at all. That has nothing to do with the problem. The 1 mile has nothing to do with the problem. Now, is this 12 minutes going to matter? Kinda, but what's going to be the important time here? Because it says here, after 10 minutes, so how much more time does the kid have? 2 minutes. That's what's important. T equals 2 minutes. So he's got to get like to the finish line over here. So like right here is boom. That's the finish line. He's got to get there in 2 minutes, and that's how far? How far does he have to go? 500 yards. But we have a problem here with the units because what they tell us is he accelerates at 0.15 meter per second squared. So does meter and yard work? No. So we gotta make the yard into meter or the meter into yard. Let's make the yard into meter. So what I did down here already, so here's the conversion, and you could probably look up a shorter conversion. These are just conversions I have in my head. So I went yard to, so the yards cancel. I went yard to feet, feet to inches, inches to centimeter, centimeter to meter. So 500 yards is equivalent to 457.2 meters. So he's got to go 457 meters in 2 minutes. What do we have to do this minute? Change it to seconds. We want all the units to work together. So 2 minutes is 120 seconds, and we're ready to go. So now we can solve it. So the question is, can the kid make it? If he, and let's just say he starts from rest. We'll say, because we can't really determine his initial velocity. So let's just say he starts from rest. V initial is 0. So how far does he go with this acceleration? So you just go x equals 1/2 at squared plus v initial t. That's the first motion equation. His initial velocity we're setting to 0. So x is 1/2. So what's his acceleration? 0.15. And then his time is 120 seconds. And we square that. So if he runs with that acceleration for 2 minutes, he will have gone 1,080 meters. Did he make it? Yeah, because how far did he have to go? Thanks. How far did he have to go? 457. How far did he actually go? 1,080. He made it. I guess the other way you could have done this problem is you could have used this x and solved for what? So notice I didn't use this 457 in the calculation. What you could have done is calculated with this acceleration and traveling that distance, how much time would it take? Right? So then you'd go x equals 1/2 at squared plus v initial t. So v initial 0. So now solve this for time. Time is square root 2x over a. So 2, now plug in the 457. So 457.2 meters. The a is 0.15. So how much time does it actually take him to run the 457? So let's see. So that's going to be 457.2 times 2 divided by 0.15. So that would take him 78 seconds. He would need 78 seconds. Does he have 78 seconds? Yeah, he's got 120. Right? So either way, you get the same answer. He makes it.